My name is Oselu Stephen Owino. I am a PhD student in Mary University of Science and Technology. I did a research in my MSc, and I'm currently also working on it, on camel milk. My supervisors were Professor Joshua Remy and Dr. Rebecca. Now, today, Kenya is the leading country in terms of camel milk production. It is the best in terms of performance. But despite that, we have a problem because there are no camel milk products in our markets. There are no products, for example, yogurt, cheese, all these value-added products. And on my research, I found out that camel milk problems has various technical problems that makes it have low consumer acceptability. So there is no any business person who is willing to venture into its business. Now, why low consumer acceptability? Number one, it has a unique structural and functional properties compared to bovine, that is cow milk. It has low amounts of kappa casein and also alpha S1 casein. And these ones are the proteins that are normally responsible for its strong texture or network. So in the end, when you have a product that does not conform to what people are not used to, you end up with a product that people reject or they have low preference rating towards. Now, low consumer acceptability comes as a result of the mouthfeel and appearance, and even overall acceptability that is low as a result of the taste and texture of camel milk yogurt. So my main objective was to produce an acceptable product, camel milk yogurt, by using different stabilizing agents and also monitor various physicochemical properties, because that is where we find the texture, viscosity, consistency, water holding capacity, synersis, and the like. Then I also did sensory analysis. So I used 3 methods to make my product. And in number 1, it was a control experiment where I used bovine milk, that is cow milk, and stabilizers. And I used sugar and cornstarch. I used 0.5. I think there is a slight mistake there. 0.5% cornstarch. And then pasteurized at 85 or 30, cooled to 42, then inoculated with thermophilic yogurt cultures, and then stored, fermented for 6 hours and stored at 4 degrees Celsius as I was awaiting for other analysis in the lab. In the second set of experiments, I only used camel milk and stabilizers, whereby I used cornstarch and modified starch at 2 to 3% and also 6% sugar, and then followed the same process to storage. And on my last method, I used camel milk stabilizers and a salt. Why a salt? Because I wanted to play around and to play with the network system of proteins in camel milk to at least strengthen the casein network, because there are some peptide bonds that also contribute to the texture of camel milk yogurt. Then I want to focus on this, although I also measured other physicochemical properties like pH, like titratable acidity, but I wanted to focus on this because of acceptability. So I measured viscosity using a rheometric method at 64%, at 64 per second shear rate. Synersis, I used the Wattman filter paper and I used, if you can see the picture on the right side, I used Wattman filter paper and left the product for 16 hours. Then I could measure the amount of water separated out. The same way for water holding capacity, I used a refrigerated centrifuge And then I could measure the amount of water that is separated after centrifugation at 4,000 rotations per minute. Then sensory analysis, because this is now, I wanted to develop an acceptable product. I did sensory analysis, and I used 32 untrained panelists, where they rated sweetness, mouthfeel, sourness, color, and even texture, and then overall acceptance. I used 9-point hedonic scale. In my results, I found out that when I included calcium chloride, the viscosity of camel milk yogurt increased further from 0.82 to 0.96 for camel milk yogurt that had cornstarch. This could be as a result of, first of all, gelation of stabilizers, and number two is destabilization of the milk protein structure. Then I also I measured water holding capacity, and I found out that adding calcium chloride increased water holding capacity of camel milk yogurt, meaning synersis separation was minimal when I added calcium chloride. Also, synersis increased, and there was a mismatch in these two because one is the opposite of the other. And when I added calcium chloride, I realized that also synersis was increasing. And this could be as a result of affecting the coagulation point of casein below its isoelectric point. In terms of sensory analysis, control yogurt, that is bovine yogurt, was the most preferred, followed by camel milk containing 2.5% modified starch and calcium chloride. Then in terms of general acceptability, control was the best, followed by camel milk yogurt that had modified starch, and then the third was cornstarch. But this could be as a result of the nature of camel milk, because it is very high in fatty acids, and also it has high concentration of salts, because camels normally feed on these herbal plants in the desert areas where water is very minimal. So my conclusion is that the viscosity of camel milk yogurt remained constant at 8.2 Pascal seconds. And also addition of salts increased the viscosity further to 9.2, but also increased synersis. Synersis is the separation of its contents and water, the watery part. So my recommendation is that despite its increasing viscosity, we should also consider the negative impacts on synersis because it also increases synersis. Then camel milk yogurt containing 2.5% modified starch and 0.075% calcium chloride was the best because it had improved texture, viscosity, water holding capacity, and it had the minimal synersis compared to the one that had cornstarch. These are some of the products, and we are in the process of patenting and commercializing. Thank you so much.